how long will this take to burn? And we asked that online and we got some answers. So let's see what we have. Full screen. So we have most of us thinking it's going to take 10 minutes to burn, some of us 5, 1, 20 minutes, and somebody thinks this is a miracle candle that will last an hour. Okay, it's a pretty good Gaussian distribution over here. I honestly don't know for sure where I am in this, but that's okay. So let me actually start a timer. Online stopwatch, and let me get this thing lit. We're going to do a little experiment here. I honestly have no idea what the answer is, so I'm very curious to see this as well. All right, while that's going, let me ask another question from all of you. And that's going to be, what do you see when you see a candle burning? So let me put this live. Activate. Okay, so the question here is, consider a candle, what do you see? So answer this in terms of physical phenomena, transients, whatever you see going on over here. And I'll try not to burn my lens here on this camera. So I see melting, fire, combustion, heat, smoke. Yes, I see all of those things. What else do we see? Energy, light, yeah, gradients, evaporation. Ooh, that's a fun one. A wick, that's a critical component here. A lot of fire, emitting, presumably emitting light or emitting heat. My house is very cold right now. It's not emitting enough. Glowing, cool. Death, all right, that got dark real quick. How about in terms of transport and the courses you've taken with respect to kinetics, heat, mass, fluids, thermo, any of that stuff? If you might draw a picture of let me try to draw a flame.
I have a quick question.
Yeah.
So could this be expressed through like a transient system?
Oh yeah.
Like a differential.
Sort of. If I asked you where is the transient, what is changing with time? Is the size of the flame changing with time?
Probably not. I'd say the height of the candle will be changing with time.
Exactly. So this is one of the things we're going to do right before your first exam, and there will be a question on your exam about it. But if you think about this process, you have the oxygen diffusing in, you have the water and CO2 going out, and these two processes, if you just take a snapshot and ignore what's going down on in the bottom, that's actually a steady state. Oxygen is always diffusing in and CO2 is always diffusing out. So there's no transient. The only transient is the consumption here. So I would actually call this a pseudo steady state.
That makes sense, because it could be it could be disturbed and it's not something that's always constant, but if given the opportunity, it will maintain a constant relationship, and you can't really express that constant, like there's no meaningful use of expressing a constant steady state relationship like through a differential equation or something.
There are, and we'll talk about them, but in this case, you can simplify it as the mass transfer being steady state, a lot of these processes being steady state or pseudo steady state. So from a heat transfer perspective, you have radiation coming from the flame, you have conduction down into the wax of the candle. That's the wax, that's the flame. So you have all sorts of heat transfer. And then just to make it more complicated, you have air currents as well going up and around that flame. So there's a whole lot of transport phenomena here. And I hope that you can see, especially by the end of this course, I hope when you look at a candle burning, you can start to realize that this is actually, oxygen diffusing into it. And this is a phase, the heat of combustion from that reaction. Oh, I didn't write any of the thermo stuff. you have a delta H of reaction all over the place. The heat being released is going down into the candle to wax it, and to melt it, all of that stuff. Okay. So that's what I see when I see a candle burn.